as we do kinematics of things with size and shape, and we talk about coupled systems, there's 4 different types of couplings that we commonly see. The first one is what I would call a gear type coupling, and that's where these two things are meshing together here. And what happens at that point is the tangential velocities have to be equal. So if we call this gear A and gear B, tangential velocity of A and the tangential velocity of B have to be the same. And same for the acceleration. The tangential acceleration of A has to equal the tangential acceleration of B. So at this point, however they're moving, acceleration and velocity have to be the same at that coupling. So that's how gears are related. We have a second type, which is belts. And that's where we have, similar to like a pulley system, but we have some belt that's wrapping all the way around, typically 2 sorts of pulleys. And in this case, our tangential accelerations sort of have to be the same everywhere. So if we have an A and a B, the tangential acceleration of A has to equal the tangential acceleration of B, and that's sort of everywhere in the system. And same with the velocity. The tangential acceleration of A has to equal the tangential acceleration of B. The difference between gears and belts, here gear A will be moving counterclockwise and gear B will be moving counterclockwise. And here gear A, if it's moving clockwise, gear B is also moving clockwise. So similar sorts of relationships. In this case, we have the same motion in terms of direction, and in gear systems, we have opposite motion direction. The third type of coupling we'll have is what I'll call shafts. And this is typically where we'll have 2 gears or 2 different things that are rotating on the same shaft. And what happens here is that all of our angular information has to be the same. So the little gear A, big gear B, omega A has to equal omega B. The angular velocities have to be the same. Angular accelerations have to be the same. And the changes in angular position have to be the same. So really everything here, they're rotating the same, but they just have different radiuses, so the velocity at a point on A will be different than the velocity at a point on B because they have different radii. That's the third type of coupling. And the fourth is a little bit different, but I'm going to call the no-slip ground condition. So typically we'll have like a wheel that's rotating across the ground and the ground isn't moving. So there's a point here at the bottom of the wheel where the velocity is equal to 0 and the tangential acceleration is equal to 0. And those 2 pieces of information can give us knowledge about how all the different points on a wheel might be moving, and especially usually the middle point or the top point. So those are the 4 general types of couplings, and we'll see problems with each of these couplings as we move through the week.